Okay, so when they go to the refraction group, you've got a choice of how many particles then get refracted. Now, if you put this to 0, that's actually exactly the same as setting this to continue. In other words, they don't bounce and they don't refract. So effectively, they just continue. So you could probably actually not use this space warp in that case and just use a normal space warp, a normal planar space warp, and just have continue turned on. So we'll put it back up to 100 so we see that all our particles get refracted, and you can see there's absolutely no effect whatsoever. So the next thing to have a look on is pass velocity, and that lets you define how much velocity is actually passed on to the particles during the refraction. It's the same as with the bounce. Now the next option is variation, and that's applied to the passing on of the velocity, and again you can actually set up a variation on that, which is a very common thing in particle flow. You know, whenever you have a bounce or a reflection or collision or any kind of value which can have some variance in it, generally you're given that option with a variation parameter, and it's no different here. Now the first real refraction parameter is distortion. What distortion does is it actually takes the angle of the bounce and it applies a distortion away from that angle of the bounce to the refraction, so it actually causes a refraction of the particles, their path. So if we actually put the distortion to 100%, you'll see what happens then is it'll actually distort the particles so that they are actually perpendicular to the collision surface, and that actually forces that. You can see 100%, it'll force that. If you go the other way, it can actually go down into negative values. At 0, 100, the particle's motion is parallel to the surface. And the only reason why they actually move away from it and start falling down is because we have a gravity space warp in this scene that actually pulls our particles downwards. So that's what distortion does. It'll actually distort your particles away from the true angle of passing through the surface. On 0, they travel on straight ahead. With a distortion, with a negative distortion, they'll move towards being parallel with the surface, and with a positive distortion, they'll move to being perpendicular with the surface. So that's the first option in terms of refraction. The second option is diffusion. So I've actually put diffusion up. Now what that actually does is to do with the direction of travel, not so much with the bounce angle. Now you can see that the direction of travel is directly straight towards us. If with a diffusion of 0, they carry on straight towards us. But if we actually change the diffusion, you can see that they actually move off that path. And if we put it up to 100%, you can see that it's actually quite a large variance away from that angle. So you can use a combination of diffusion and distortion, there we go, to actually influence the way that your particles are actually distorted. So you can see that by using diffusion and distortion, we've actually got some particles here which are actually traveling back in the opposite direction. So you can see you've actually got a wide variety of distortion there. Now you can actually achieve similar effects to this just by using different speed operators in events when particles have actually collided. So that's another way of achieving this kind of effect. But if you actually want the effect to be in the actual collision space warp, then you can do it this way. The variation parameter for both the distortion and the diffusion, it's actually a multiplier. So we'll actually get rid of some of the diffusion for a second, and you can see we've got a distortion of 100. Now if I actually put that up to 100, you can see it's actually causing the particles to go back in the opposite direction. Now that actually means that this is a multiplier, so it's not only distorting to the point where the particles are actually traveling off perpendicular with the surface, it's actually pushing them 100% beyond that, so that now they're going at the opposite angle to the angle that they actually came in at. So it's a multiplier, and you must remember that. So if, for instance, we have a distortion of 0, and you multiply that by 100, you have no variation, and you can see the particles travel onwards. If we have a distortion of minus 100, you can see that if I actually change the variation back down to 0, you can see actually does have an effect. So there you go. And it's the same deal with diffusion variation as well. It works in the same way. Beyond that, the other unique parameters to this particular set of collision space warps are the time on and time off parameters. Now these are both a blessing and a curse, because obviously they're good in that you can actually use these parameters to